Johannesburg, very, very clear skies tonight, which means that you can faintly make out the moon as it passes through the Earth's atmosphere, and that shadow is cast onto the moon. You can just faintly make it out, so it's not complete blackness. A lot of people have gathered here. It's very exciting to actually witness something like that. Just a little while ago, it was a lot more red, and that, of course, elicited gasps and excitement, and some people started howling at the moon.
I love that, howling at the moon. So, Deborah, how long will it last with this red tone that we're seeing right now?
Well, this is the longest lunar eclipse of the 21st century. So the whole eclipse will take 1 hour and 43 minutes. The red won't last that long, though. It's starting to fade a little bit now, and as it moves out of the Earth's atmosphere, you will see it less and less and less. So I think the best part has already happened for people here.
Now, you're at the planetarium, so I would imagine there are a lot of people there with you. You said some people were gasping and howling at the moon. How many people are there near you?
Well, there's a couple of hundred. They've set up telescopes, so everyone's looking at them. And people have made this into a huge outing. There's a family nearby. They're picnicking. They brought their 3 children who said they'd rather come and watch the moon go red than go to a party. So I think that says something. And of course, this being modern times, everyone is trying to take a selfie with the moon. I'm not sure how that's actually working out. It's quite difficult to get logistically, but everyone's doing their little selfie bit here right now, and trying to get that absolutely perfect picture that they can post on whatever social media site they're using.
So is the sky particularly clear there tonight? I mean, we're looking at a very clear picture of the moon from a camera, I believe, that is in Johannesburg, as you are as well. Has the sky and the weather cooperated?
The weather has. This is winter in South Africa. It's very cold for us, at least here. And so what means in Johannesburg when there's winter is that we have clear skies. There's no rain during the winter season. So we have these absolutely clear skies, no cloud. It was clear the entire day. It couldn't be more perfect weather conditions. And bear in mind, this is a city, so it's not even the best viewing point in South Africa, because obviously the more you move away from the city lights, the better the image even is. But even in the city, it's been absolutely clear, and everybody has been able to come outside onto their balconies, into their gardens, or just come to a public place like the planetarium and get this once in a lifetime, once in a century opportunity to see this longest lunar eclipse. Next to this bright red moon, you also got this small little orange blob, and that's Mars, which is, you know, the closest it's been to the Earth in 15 years. So it really is a treat for people here tonight.
And Deborah, you've spoken with many astronomers, many scientists about this phenomenon. What did they tell you, and what are they looking for?
Well, what is unique about this is that everything has to be in perfect alignment. You've got the moon, you've got the Earth, and then you've got the sun. And it can only happen when it's a full moon. When that happens, when everything is in alignment, that's when you get a total lunar eclipse. Why everyone is excited is because you won't see it in a full total way for this long for another 100 years. There will be more eclipses along the way. So I think that's what's got everybody excited here in South Africa, and of course across the rest of the continent. So that's essentially what they're looking for, that perfect alignment. And then as the moon passes through the Earth's shadow, the shadow is cast onto the moon, little bits of the sun creep through, and you get this red light, and that's where you get this colloquial term, the nickname a blood moon, a term that the scientists don't like, but it captures really the thrill that everybody experiences here. You don't often get to see a moon this color. What they're also looking for is the fact that the moon is the furthest distance from the planet. So at the beginning of the year, when you had that big super blue moon, it was the closest it was to the planet. So the moon looked a lot bigger. Tonight, it's what's known as a mini moon, a micro moon. It's far away, but just beautifully lit up and red.
It is beautiful. And Deborah, you spoke with experts who discussed the meaning of these blood moons to pre-industrial societies that didn't have the knowledge of astronomy, clearly, that we have today. What were some of the signs that these societies used to attribute to the blood moon?
Well, we can imagine it was terrifying in ancient times. The moon would suddenly disappear, or the moon would turn red, and if you told time by the moon or worshipped the moon, this was terrifying. A lot of people believe that the gods were angry. The Inca, for example, believed that the jaguar was eating the moon, so they'd all gather outside and bang pots and make their dogs howl to try and chase the jaguar away. In other ancient parts, they believed that it was a direct attack on the king, and that you'd get a proxy king who would sit on the throne during the time of a lunar eclipse to ensure that the king wasn't attacked. So a lot of ancient beliefs, for most people, it was a bad omen. It signified maybe drought or terrible weather or something awful was going to happen. It was never a good sign. But of course, now we know with precision when it's going to occur. It's not terrifying, it's just exciting and a chance to take a selfie.
I can imagine how terrifying it must have been. You know, Deborah, one of the things that some of the experts we've been talking to say is that you know, scientists knew when this was going to happen. They knew how long it was going to last. What they didn't know, though, was the exact hue that the blood moon would take on. How would you describe the color from there? Of course, we're looking through a monitor, so we don't get the exact color that you see with the naked eye. How would you describe it?
Well, that's the amazing thing. You can see it with the naked eye. You don't actually need a telescope. At its peak, it was certainly red. It's not sort of bright red because it's mottled, because you've got, you know, there's the shadow over it. And also we're in Johannesburg, so there's an amount of pollution, perhaps debris, dust, anything like that can get in the way. We don't have cloud cover, so it's probably one of its brightest here. And the more you move away from the city lights, so, for example, we were speaking to friends and family who were far away where it was in a farming community and they were seeing a much brighter red moon. But even for us here in Johannesburg, it was pretty red at its peak.
Very exciting. Deborah Pata in Johannesburg, South Africa. Thank you. And here to talk about this cosmic phenomenon is Hakeem Oloshei. He is a professor of physics and space science at the Florida Institute of Technology. Hakeem, thank you for joining us. Can you explain?
Thank you for having me.
Thank you. Can you explain for us exactly what's happening?
Yeah, so if you look at the Earth at all times, because it's orbiting the sun, it has this long shadow that extends out from it. And the moon is very far away. If you look at the distance from the center of the Earth to the surface of the Earth, the Earth radii, the moon is about 65 Earth radii away. So it's very far. And what's happening right now is that the moon is at its farthest point in its orbit. Its orbit around the Earth is not a perfect circle. It's what we call an ellipse. Sometimes it's closer, sometimes it's farther away. And when it's closer, it moves more quickly. And when it's farther away, it moves more slowly. And so right now, it's very far away, and if you look at the shape of Earth's shadow, the moon could pass through the edge, or it can pass through the center or somewhere in between. This time, the moon is very far away and is going right through the center of the shadow. That makes it an incredibly long lunar eclipse. Now, what we're seeing right now is the moon just went in totality. The Earth's shadow has two parts. It has the dark inner part where the light is completely blocked. If you're standing on the moon's surface, you can't see the sun. You see a ring around the Earth, and it's a total eclipse. But if you're on the Earth, then the entire hemisphere on the Earth facing the moon, where it's night, gets to see the eclipse. We're on the other side, so we can't see it. We're still in the daylight. But the Earth's atmosphere bends the light so it falls on the moon, but it also filters the light. The blue light gets scattered out by a process we call Rayleigh scattering. The red light makes it through, so this little bit of red light is filtering through, falling on the moon, and we get this blood moon and this very long once-in-a-century eclipse.
And so that's why it's red. Very interesting. Now,
Yeah.
Hakeem, this is the longest eclipse of the century so far. Will there be a longer one?
Well, if you go and look up the lunar eclipses that are occurring, what you have to look for is when there's going to be a central eclipse, meaning the moon goes right through the center of the Earth's shadow, and that eclipse occurring when the moon is near its farthest point from the Earth. So this one has both of those conditions. There's not another one this century that has both of those conditions, but we can predict these things far into the future. There is, in fact, a website that shows you photographs of how the moon will pass through the Earth's shadow and where it'll be in its orbit. So you can go and look, and if you can hang around for a few hundred years, you'll get to see another one.
And can we imagine that the temperature on the moon has dropped now that the sun is not directly hitting it?
Well, you can imagine that, right? Because when the sun's rays are directly falling on a surface, then, here we are on Earth, and we have an atmosphere that is able to filter out a lot of the radiation that we're not receiving. A lot of the ultraviolet is filtered out. A lot of the infrared is filtered out. The moon doesn't have an atmosphere. So when the sunlight is falling directly on it, if you had something there measuring the temperatures, you would measure a high rate of solar energy being absorbed on that surface. But now that it's being blocked out, you can imagine that that radiation is blocked out, so you don't get that energy. So in fact, you're colder.
Right. Now, we have seen a lot of interest in this event.
Yes.
What does it mean for the scientific community? Are you guys excited about this sort of interest?
We certainly are, because a rising tide floats all boats, and the scientific innovation comes from scientific inspiration. And so getting young people involved, letting the public know that this is something that is worth your tax dollars to invest in, because you can think about, we've heard of people that invest in businesses and startups and this sort of thing. Well, basic scientific investment is like investing in startups that don't yet exist. And the nations that do that are the nations that are going to prosper in the future. So once we get everybody excited about science and we recognize its importance, that not only improves our lives through the scientific things that we learn about the universe and the engineering that creates new stuff to make our lives better, but it also creates more prosperity for us.
Yeah, young people getting excited about science is always a good thing. I just want to point out,
Certainly.
We're looking at a picture right now of the blood red moon over on the left-hand side, and
Yes.
a sort of bright star up in the right-hand corner.
Yeah.
That's Mars, right?
That's right. Yeah. So this is an interesting thing. When we have a full moon, then that means that the sun, Earth, and the moon are lined up. Well, right now, Mars is at what we astronomers call opposition. So Mars is on that line too. So right now, the Earth, the sun, Earth, moon, and Mars are all in a line, and that's why we're looking past the moon out to Mars, which is tens of millions of light years away, somewhere between 40 and 50 million light years away. So we have a full moon during this eclipse, and we also have a full Mars.
And what's going on, on Mars? If we're talking about the moon, dropping temperature and what it would be like on what's happening on Mars right now?
Well, Mars, what Mars would see potentially would be when we look at Venus pass in front of the face of the sun, we call that a transit. So I don't know if they're lined up sufficiently for there to be an Earth transit, but that's about it, because Earth's shadow does not extend that far, but it's similar to the way we discover planets around other stars. When the planet passes in front of the disk of the star, you get a little drop in the brightness. So if you were a scientist on Mars right now, you could be taking data and you might be able to see the Earth-Moon system blocking out some of that light. And if you didn't have enough resolution to see that they're two separate bodies, you'd be able to figure it out from that data. But you wouldn't be able to figure out this time because the moon is in the Earth's shadow, so you'd miss the moon. But potentially, you could do that at other times.
And Hakeem, let's say you're Neil Armstrong, you've landed on the moon at the time of the lunar eclipse. You look up, what would you see?
That is a beautiful question. So again, the Earth's shadow is complex. There's a dark inner region we call the umbra, and then there's a region around the outside. So at first, what happens is the moon passes into that outside region. So if you're Neil Armstrong on the moon, you would see a chunk taken out of the sun from your perspective on the moon. And then you see the Earth, as it passes, you see more and more of the sun getting blocked out. And now imagine, though, the Earth's shadow is way bigger than the size of the sun is. So, you'd have this big arc covering the sun. And then once totality start, that would be a full eclipse. So you wouldn't be able to see the sun at all. And you'd see the Earth with this red ring around it where the light is being filtered through the atmosphere. atmosphere.
Wow, that sounds like a pretty cool view as well.
It would be.
Well,
yeah.
Hakeem Oluseyi, thank you so much for talking with us today.
Me. Wonderful.
And we're going to take a quick break now, but when we return, we'll have the rest of the day's news. You're streaming CBSN, CBS News, always on. Michael Cohen once told Vanity Fair he would take a bullet for President Trump. Now he says he's willing to cooperate with the Mueller investigation, and his old boss isn't happy about it. Nicole Killian is at the White House.
President Trump touted the economy during an impromptu press conference on the South Lawn this morning.
I am thrilled to announce that in the second quarter of this year, the United States economy grew at the amazing rate of 4.1%.
But he did not respond to news reports his former lawyer and longtime fixer Michael Cohen is now prepared to tell special counsel Robert Mueller Mr. Trump knew ahead of time about a June 2016 meeting with a Russian lawyer in Trump Tower. That meeting included Donald Trump Jr., the president's son-in-law Jared Kushner, campaign manager Paul Manafort, and Natalia Veselnitskaya, a Russian lawyer who was promising to bring damaging information about Hillary Clinton.
No, I didn't know anything about them. It must have been